Welcome back, guys, and what we're going to be looking at in this tutorial is an arithmetic series. So in the last tutorial we were looking at an arithmetic sequence or pattern. An arithmetic pattern would be written as 4, 11, 18, 25, ... And the reason why it's a pattern, you can see, is that there's a comma in between each, and that's what makes it a pattern or a sequence. Okay, compared to what we're looking at today is an arithmetic series, is where we take that sequence and instead of writing it as a pattern, I am going to add all of the terms together to make what's called a series. So a series is formed when each term of a sequence is added together, which is what you can see written here. When there's a plus in between each term, that's what makes it a series rather than a sequence. Now, when we're looking at a series, to find the sum of a series, which is every term added together, we use our SN formula, which is called the sum of a series formula, which can be found there on page 22 in your log tables, just underneath where we were looking at the arithmetic series. So again, we have A stands for our first term, that bracket should be on this side. D stands for our common difference, and N is the term in the sequence. So if we look at example 1 here, it says find the sum of the series 4 plus 11 plus 18 plus 25 plus ... all the way up to 144. So as soon as I see the word sum of a series, I know that I'm going to use the SN formula, which is n over 2 by 2a plus n minus 1 times d. The only problem is to find the sum of this series, I need to know what this last term is. But at the moment, right now, I don't know what n is. So before I can find the sum of the series, step 1 is I need to find n. Okay, so step 1 is to find n. And to find n, we're going to go back and we're going to use our Tn formula. So here we have Tn is equal to a plus n minus 1 times d. I can see that a is 4, and I can see that each time it's going up by 7, so d is 7. And I want to know which term 144 is. So I'm going to sub that in for Tn is equal to 4 plus n minus 1 times 7. So I get 144 is equal to 4 plus 7n minus 7. So I get 144 is equal to 7n plus 3, minus 3, sorry. Because 4 minus 7 is going to give me minus 3. So I'm going to bring my 3 over and it's going to become a plus. So I get 147 is equal to 7n. And then to find n, I'm going to divide both sides here by 7. So now when I do that, I get 147 divided by 7, which is going to give me 21. So that means now I know, therefore, term 21 is equal to 144, which we're going to use now for step 2, where step 2 is going to be to use my SN formula to find the sum of the series. So I'm going to do S of 21. Instead of n, I'm going to sub in 21 over 2 by 2a, which I know is 4, plus 21 minus 1 times d, which I know is 7. Now, I'm going to go through this where we have 2 by 4 is 8, 21 minus 1 is 20, and 20 by 7 is 140. So then I get 21 over 2 by 148, which I'm going to put into my calculator here, because again, I like to show my workings where I can. So 21 over 2 by 148 gives me 1554. So all of the first 21 terms added together gives me 1554. So if you want, guys, take a second, pause the video here before we go on to example 2. But when you're ready, we're going to move on now to example 2, which is where we're going to take what we've just learned and put it in context. So it says, to celebrate the birth of his niece, an uncle offers to open a savings account with a deposit of €50. So that means I know in the first year, €50 was put in. He also offers to every year add 10 more than he did the previous year, which means next year he would add 60, then he would add 70, then he would add 80, and then it would keep going. And because I can see here that to go from 50 to 60 and 60 to 70, that each time it's increasing by 10, I know that it's an arithmetic sequence. It says find an expression for Sn, the sum of the money after n years. So now it wants just the general version here. So we have that our Sn formula is equal to n over 2 by 2a plus n minus 1 times d. So again, I'm not going to sub in for n this time because it wants Sn in terms of n years. But I know my first term is going to be 50. So a is 50 plus n minus 1 times 10 because each year it increases by 10. So I get n over 2 times 100 plus 10n minus 10. So I get n over 2 by 10n plus 90. And this is the point, guys, where what we're going to do with this n over 2. Okay, so what we're going to do here with this n over 2, if it lets me. Anytime now, screen. Is we're going to take that n over 2 and we're going to divide by the bottom and multiply by the top. Okay. Now, to divide by the bottom here, we divide by 2. So 2 goes into 10 5 times, and then we multiply it by n, which means I get 5n squared. 2 goes into 90 45 times, multiply it by n, gives me n. So at the end of all this now, I have therefore Sn is equal to 5n squared plus 45n, which we're now going to use for part 2, where it says find S21. The total saved after 21 years, which means now we're just going to take our Sn formula from our last answer and we're going to sub in 21 to find the total amount that she'd have after 21 years. So we have 5 by 21 squared plus 45 by 21, which we can put straight into our calculator now, which gives me 3,150 euro, which I'm going to put in context of the question, so making sure I have my euro sign. So again, guys, if you want to pause the video here, we're going to move on to example 3 when you're ready. So looking at example 3 here, we have another rule to apply, which is given that Sn to find Tn, that means we know that Sn minus Sn minus 1, so the sum up to one term minus the sum up to the term before will give me Tn. So this is going to be a nice bit of algebra revision here, because it says given that Sn is equal to n squared minus 4n, find an expression for Tn. So I have Sn, but I need to know Sn minus 1. And just to note, guys, this formula is not in our log tables, so this is one we need to know. So Sn minus 1, everywhere I have an n in my Sn formula, I'm going to sub in n minus 1. So I have n minus 1 squared minus 4. Minus 4 by n minus 1. Minus 4 by n minus 1. So I'm going to use the perfect square formula to square him out. If you want to split the brackets and multiply, that's up to you. And then I see I have n squared minus 6n plus 5. So now I'm going to use my formula. Tn is equal to Sn minus 1, Sn minus Sn minus 1, apologies, which now we're going to sub in here what we know. Okay, so to sub in here what we know, instead of Sn, we're going to sub in n squared minus 4n minus n squared minus 6n plus 5. Now that minus here is going to make him a minus, him a plus, and him a minus, which means I'm going to have n squared minus 4n minus n squared plus 6n minus 5. My n squareds are going to cancel like this. And now what I'll see is that I'm going to have 6n minus 4n is going to give me 2n minus 5. So therefore, Tn is equal to 2n minus 5. And that's the first part of the question there, where it says to find an expression for Tn, this part here. But what you're going to notice is it says hence determine if the sequence is arithmetic. So for the second part here, This is where we're actually going to go back now and use the rule that we learned in the first video, which is that if a sequence is arithmetic, tn plus 1 minus tn will give me a constant, which is my common difference. So we have tn, which is 2n minus 5. Now we need to have tn plus 1, so I'm going to sub in n plus 1 for n, which gives me 2n plus 2 minus 5. So I get 2n minus 3. So now I'm going to sub it in and see what happens. Tn plus 1 would be tn minus 3, minus tn, which would 2n minus 5, and we'll see what it equals. So that gives me 2n minus 3 minus 2n plus 5. So my 2n's cancel. I get 5 minus 3 is 2, which is a constant. So therefore, tn plus 1 minus tn is equal to a constant. So the sequence is arithmetic. Okay? So again, that brings back in something we did in the first video. So it's important that all of our knowledge links together, guys, because it's going to come up again and again and again. So if you want to pause the video here, look back over it again, or add this into your notes. The last thing we're going to move on to in this one is using what's called sigma notation. Now, in arithmetic series using sigma notation, this symbol in Latin, sigma, means the sum of. So we can use this instead of using Sn, but we have to be careful here. If you look at this example here where it has 4 over sigma, or is equal to 1, 4 refers to that there's the first 4 terms, t1, 2, 3 and 4, and I know it starts at t1 because or is equal to 1. Sigma tells me that I'm adding the first 4 terms together, but this t or is really representative of my tn function, but it just uses an or instead. So this is not my Sn, this is my tn that goes in here. So if we look at part 1 here, it says use sigma notation to represent 2 plus 6 plus 10 plus 14 for the first 45 terms. Now be careful here, it doesn't actually say find the sum of the first 45 terms. It just says to use sigma notation. And to use sigma notation like this guy, 45 is going to go on top. Because it's the first 45 terms, I know or is equal to 1, but what right now I don't know is tn. So this actually brings me back to using my tn formula with my series here. So my first term is 2 plus n minus 1 times, it's going up by 4. And I multiply it out, which gives me 4n minus 4. So I get 4n plus 2 is tn. But to use sigma notation, we don't use n, we usually use or. So that means the sum of the first 45 terms would be sigma with 45 on top and or is equal to 1 to show we're starting at term 1, 4 or plus 2. And that's simply how we would write to find the sum of the first 45 terms using sigma notation. So bearing that in mind here, we're going to have a look here at part 2. Part 2 says for what value of n, so this time I don't know n, that's a question mark. But it starts at or is equal to 1, is 3 or minus 5 equal to 90. Now be careful, that 3 or is tn. So if tn is equal to 3n minus 5, the first thing I do is I would always find the first 3 terms to start getting a pattern. So t1 would be 3 by 1 minus 5, which is minus 2. t2 would be 3 by 2 minus 5, which is 1. And t3 would be 3 by 3 minus 5, which is 4. So my pattern is starting to look like minus 2, 1, 4, dot, dot, dot. So I can see it's arithmetic and that it's going up by plus 3. So that means A would be equal to minus 2, D would be equal to plus 3, but I don't know what n is here. But I do know that the sum, Sn, would be equal to 90, because that's given to me here in the question. So this is now where I'm going to take my information and use the Sn formula, which is equal to n over 2 by 2a plus n minus 1 times d. So instead of Sn, I'm going to sub in 90, because that's what the sum is. N over 2 by 2 by a, which is minus 2, plus n minus 1 times d, which I know is plus 3. And I start to multiply out. So I have n over 2 by minus 4 plus 3n minus 3. So I get 90 is equal to n over 2 by 3n minus 7. And again here, when I'm going to divide by the bottom, multiply by the top, gives me 3n squared all over 2 minus 7n all over 2. So at this point I can see it's starting to head into a quadratic. So to start off, I'm going to multiply everything by 2 here to get rid of my fractions. And then I'm going to move everything over so that one side is equal to 0. So that gives me 180 is equal to 3n squared minus 7n. I'm going to move my 180 over, which gives me this. And now what I'm going to do is use a quick minus b formula here on my calculator so that I can solve this as quick as I can to find two values of n. So I have 7 plus the square root of 7 squared minus 4 by 3 by minus 180 all over 2 by 3, which gives me n is equal to 9. And then I'm going to have the negative version, which I go back and just change the sign in between the 7 and the square root to a negative. And I get n is equal to negative 20 over 3. Now be careful here, guys. As we said in the first video, n can only ever be a positive whole number, which means when we look at our two answers here, we know that we accept n is equal to 9 and we reject negative 20 over 3 because it is neither positive nor whole. So now I'd write out my answer of therefore sigma of the first 9 terms when or is equal to 1 of 3 or minus 5 would be equal to 90. Okay? Again, there's a lot in these questions, guys, for example 4, so it could be worth your while pausing the video here before we look at part 3. But part 3 is a little bit more straightforward. So part 2 was the longest, part 3 is going to be a little bit more straightforward. Because it says, find the value of the first 8 terms added together when or is equal to 1 of 4 or minus 1. Now again, to be able to use the SN formula, which is really what it's asking me to do here, because remember, what they've given me here is Tn. To be able to use the SN formula, I'm going to use the Tn that they've given me to find A and to find D. So to start off here, I know Tn is equal to 4n minus 1. So I'm going to find T1, which is 4 by 1 minus 1, which is 3. T2, which is 4 by 2 minus 1, which is 7. And T3, which is 4 by 3 minus 1, which is 11. So I can see my pattern here is 3, 7, 11, dot, dot, dot. So A is going to be 3, and my common difference is going to be 4. And they've told me at the start of the question that they want the sum of the first 8 terms, so n would be 8. So that means then I'm going to use my SN formula, which is n over 2 by 2a plus n minus 1 times d. So I'm looking for S8, so I'm going to have 8 over 2 by 2 by 3 plus 8 minus 1 times 4. So I get 4 by 6 plus 7 by 4, which is 28. So I get 4 by 28 plus 6, which is 34. So to finish off here, 4 by 34, which gives me 136. And we're happy days. Alright guys, so that's the end of our tutorial here on Arithmetic Series. So take a minute, go back through it, make sure we understand it, and then when